Hello, everyone. Welcome to our third installment of the CDK workshop series. So first of all, if you're new to the channel, welcome. Feel free to say hello in the chat. I'd love to, just see where you're viewing from and what you're looking to see and what kind of content you're looking to get out of the channel. Always love to hear feedback. We bring that back and then we just build more content tailored to what everybody wants to see. And if you've been here before, welcome back. It's always good to have you here. So what we're going to do today is we're going to walk through the third chapter in the CDK workshop, which is where we're going to actually create our own reusable construct. So let's just get started with the screen share so I can start walking through some of the concepts here. So in the first session, which I will post the banner here. So in our first session, we walked through getting started with the CDK. And by the way, this workshop series is using TypeScript. Definitely plan on seeing another iteration of this series using Python in the coming months. So we started by initializing our project. We installed all of the necessary packages, Node, all the libraries we needed to run. We installed the CDK. We initialized our project. We bootstrapped our repo. We bootstrapped our region and account. And then we went ahead and synthesized some of our CDK code and then deployed a very simple basic SQSQ. Then in the second installment, so this is going to be session 2, which you see in the link here. And in this session, we went a little further. So we went, we had our account and region bootstrapped. We had all the basics done. And in the second chapter, we actually created a Lambda function. We created an API gateway, integrated that Lambda function with that API gateway, and then we were able to test that in real time, deploy it in real time. And in addition, we walked through the local development experience when you're building Lambda functions with the CDK. We talked about the CDK watch command, as well as the hot swap command. So definitely check out session 2. To get more details and to watch how we did that. Now we're moving into the third installment here. So first of all, welcome everybody. So we got, this is cool, Quebec. Hey, welcome, Christian. Thanks for joining. And then Colombia. Welcome, Carlos. Very cool. I'm so bad with time zones, so I have no idea what time zones you're in, but hopefully it's not, the middle of the night and you can't sleep. But maybe I'll help you, fall asleep. Who knows? Okay, so in this iteration, I'm gonna do this first, and we'll zoom in a little bit. So now we're gonna focus on building constructs. So the construct is really a foundational component of the AWS CDK. This is how you build reusability, and we have different levels of constructs with the libraries that the CDK library provides behind or within the package. And to see those levels, check out our channel, CDK Live. We do have a walkthrough of the different level of constructs and the level of abstraction that comes with each one. But generally, think of constructs as just building reusability into your infrastructure as code. It's very common that you're going to want to do the same thing over and over again. And as we know, when we're writing code, we don't want to keep repeating that same code over and over again if we don't have to. So writing constructs is a great way to generalize a use case and then reuse that chunk of code with, maybe different parameters based on the use case, based on the environment. And that construct, that, module will essentially build those resources based on that generic pattern that you've defined within that construct. So in this case, we've deployed our API gateway, we've deployed a Lambda function, and that returns basically that Lambda function we deployed returns the path that we called, which actually, let's see if I may have to redeploy the stack. Didn't think about that. Cool. So we have our API gateway endpoint here. And if I were to curl this, you could see this is what our application returns. So I happen to, make that CDK watch because during the last episode, we used the CDK watch command when we were playing with this. So you can see if I hit prod CDK/live prod hello world, it is just returning, the path. Obviously, this is a demo application, but the idea here is just to showcase how you can use the CDK to deploy, applications based on your needs. So what we're going to do now is we're actually going to create a construct called the hit counter construct. And this construct is going to generalize a pattern, which is to create a Lambda function. And then that Lambda function will invoke the backend function that we've already defined here. So our hello function. And it's also going to deploy a database, a DynamoDB table. And within that DynamoDB table, that Lambda function will have access to it. It's going to write to that table the requests that come in, so we can track our who's accessing what within our demo fake application. So let's get started. And again, feel free to follow along here. And if you want to do this on your own, just know that when we're done, make sure you always run a CDK destroy the resources when you're done with them. You don't want to be paying for things that you're not using. Although if it's a brand new account, a lot of these resources are in the free tier. But anyway, don't quote me on exactly that, but just destroy when you're done. Okay, so the first thing we're going to do is we're going to go to our lib directory, and we have our CDK workshop stack code. So you see here, this is our CDK workshop stack code. We're creating our Lambda function. We're creating our API gateway, and then we're actually leveraging a construct here, a higher level construct called the Lambda REST API construct. And what this library does is it will automatically integrate with a Lambda function on the back end. So, as you go up with constructs when using the CDK, as you go up the levels, the more abstraction that's built in, defaults, good practices, and so on. So we're going to create a new file, and we're going to call this file hitcounter.ts. Okay. And here we're just going to do some imports now. So we're going to import the CDK, first of all, from the AWS CDK lib. Oops. Let's do from, because sometimes reading can be hard. And hopefully if you can't see, or if it's if you want me to zoom in a little more, let me know. I'll just do one extra zoom. It just becomes harder to read here for me, but it's okay. I'm here for you. Okay, so let's also import the Lambda construct library. So we're going to import all as Lambda. And then quick shout out, Amazon Q developer. If you are not, and I did this in the last session and the session before, but it's just every time I use Q and I use the Gen AI code assistance, it makes me think, how did I live this life as a developer, without this? So as you can see, it's auto completing for me, and it saves me a lot of time with a lot of these kind of menial tasks. So, and actually a little later, if we have some time, we're going to use Amazon Q to rewrite some of our code. So the last thing we want to do is import the construct library, if I can spell, from constructs. And now let's start by creating our interface. So we're going to create our interface. Now this interface, counter props, and then we'll do this. So this interface is going to be that entry point into our construct. So when you're building reusability, there's a high chance that you're going to want to provide some inputs to that construct to then do the needful based on those inputs. So in this case, this construct is going to require that downstream Lambda function, because if you remember the architecture over here, it invokes that Lambda function that we created outside of the construct. So we want to make sure that we can pass in the Lambda function into our construct, so then we can actually work with that within our code. So what we're going to do is we will name this downstream, and then we're going to type this to Lambda I function. So what we're saying is that when you the entry point, which we'll do in just a minute. And by the way, as you can see, Amazon Q did its magic. It did all this for me, which is really neat. I'm not going to let it do everything here because I want to type it out myself. But again, look how cool that is. So this is our entry point into our application, into our construct that we're building. So now what we're going to do is create our construct class. So again, we're going to do export class, hit counter, and then we're going to say that it extends the construct class. And then we'll close this off, construct, and then export class. And again, spelling. There we go. Spelling is hard. Okay. So now what we want to do is create our constructor here, define our constructor, which will then be the scope, which is going to be the construct, the ID, which is the ID for the resources being created, that unique ID. So every time you create this construct, it'll have a unique ID. And then we're going to pass in the hit counter props that we defined above. And then we'll do super scope ID. Okay. So let's see what I spelled wrong here. And you can see here, I forgot the most important thing here to put that in brackets. Okay. All right. So now we have a shell of a construct. This is our shell. Again, we have our interface, which is saying that we require, because we're not making this optional. So we're saying this construct requires as an input a Lambda function to be passed in, and it's strongly typed. So I can't just pass anything in. I have to pass in the Lambda function object. And we're saying in our constructor here that we want to leverage these hit counter props, which, let's see here. Let's make sure. Spelling. See, spelling's important. Okay. So this is it. This is like our shell and where we're going to get started, and we're going to move on from here. Okay. So now what we want to do is start defining some of the code that our construct's going to use to build our resources. But before we do that, the first thing we want to do is we're going to create our Lambda function. So the Lambda function that is going to be that pass-through Lambda function that writes the Dynamo table, we're going to want to write that, create that code and bundle it as a part of our CDK app. So I'm going to go back here. And so this is the one case where I'm going to copy paste. So don't be mad at me for that. And then we're going to name this hitcounter.js. Now, what I mentioned earlier was we're going to use Amazon Q to change some code here and to get some suggestions. And what we're going to do is this is using the AWS SDK v2, which is the older version of the SDK for Node.js or for JavaScript. The latest v3 is the one we should be using. So later on, we're going to ask Q to upgrade this code for us, and we're going to see how that works. So this is our code for our Lambda function. So a couple of things that you're going to notice here in this code, and let's see, maybe I'll even go out a little bit. Perfect. Number one, that we're looking for in order to update our table. So very common that when you're writing applications and you want to build reusability into your applications, you're going to leverage environment variables as the kind of dynamic, as resources are dynamic and change based on environment. So what we're doing here is with this Lambda function, we're looking at the environment variable for the DynamoDB table name. So when we create this function, we're going to have to make sure that we export that environment variable, that we pass in that environment variable to the Lambda function. And then the same goes with that downstream function that this application is going to call. Okay, so that's our application code. And now what we're going to do is we're going to go back and we're going to actually create our resources. So remember, you don't want to hard code things. Like if I were to hard code the table name here, that's not great. That's not a good practice. We need to be dynamic, especially when you're using infrastructure as code. We want to make sure that everything we're building is dynamic. So we have Lambda. Let's also add DynamoDB. Thank you. And then let us create our resources. So the first thing we want to do is in our construct, we want to make sure that the Lambda is the Lambda object for that front end function is available to the object. So it's an available property when we actually create the object outside of the construct here. So we're going to make this a public resource, and we're going to say handler, and we're going to make this lambda.function. So that handler object is going to be accessible outside when we want to reference it in our code, which we'll look at in just a little bit. So let's create a DynamoDB table. That's the first thing we're going to do is we're going to create a DynamoDB table. DynamoDB.table. Again, we're passing in the scope, which is the scope of this construct. And then we're going to name this hits, which is the ID. And then we will also create a partition key here. So you can see all the options available to me. The one required option is partition key. So we're going to name that path, and it's going to be a string attribute type. So we created our DynamoDB table. As you can see, it's just a couple lines of code. Again, leveraging these higher level abstractions. The other thing to point out here too is there is a DynamoDB v2, table v2 construct that you should be using. We just have some code here that's a little bit outdated. So I'm going to be updating that after this series. Okay, so we have our Dynamo table. Now we want to create our Lambda handler. So we're going to say this.handler. Again, that resource is a publicly accessible resource. So it's accessible when we create this object. And we're going to say new lambda.function. Again, pass in the scope. And we'll name this hit counter handler. And now we have all of these properties available to us to create this function. So let's see. Hey, Connor, what's up? Hey, what's up? Going through the CDK migration literally right now. Like, Connor, right this second. Like, that's awesome. I mean, first of all, reach out if you have any questions. Glad to answer them, but that's super awesome. Glad to hear you're on that journey. I just quick little, backstory. I've been writing infrastructure as code since it came out, since infrastructure as code became a thing. If you remember, previous to infrastructure code as code, it was configuration as code. So that's where Chef, Puppet, Ansible, all these really cool tools came out. And I got to tell you, once I got to a point where we got to a point where we advanced to where you could now define your infrastructure as code using a programming language, but on top of that, leverage abstractions and really cool helper methods and helpful helper methods to make your life a lot easier. I never look back. So, and we'll see a couple of examples of those helper methods. Spoiler alert, it's like the grant read method for a Dynamo table, grant read write. So rather than having to author all of these IAM policies, I can leverage these abstractions that are built into the CDK. So that's my quick little story there. But I've been using the CDK since its very early days, and it's just grown into such an awesome tool. And you can just see it when you talk to people in the community, their passion, how much they love it, and so on. So, and that's really cool. So awesome. Keep in touch. I really want to hear how that goes, and it, as you progress. And hey, maybe we'll do a CDK live show and we'll talk about your migration when it's all done. That would be really cool. Okay, so let's set our runtime. So again, really cool, really good helper methods available, enums. So I'm going to leverage this enum here to choose the runtime for my function. So again, I'm going to be updating this in the workshop. Don't be mad at me, but we shouldn't be using node 14. So in this case, let's go to node, let's go to 16, and then we'll go to 18 a little later. So we're going to set our runtime, and then we want to define what our Lambda handler is. So the Lambda handler in this case is going to be that file name, and then the method, that function that the Lambda function is going to call when it triggers that function. So we're going to call it hitCounter.handler, because if you look at our code, exports.handler. So that is our handler method. And you can see the IDE is still telling me I need more here. So now what we're going to do is add our code. Now, I talk about abstractions all the time. It's annoying. And I talk about how cool the CDK is. So I get it. But this is another really helpful abstraction. And that is the assets that are managed in the CDK. So one big struggle is deploying your applications, finding a way to deploy your applications, and then you also have to deploy your infrastructure or your cloud resources. So you're deploying Lambda functions, deploying your infrastructure as, you're deploying your applications, you're deploying your infrastructure as code. You have to think about how to bridge those together. 2 pipelines, single pipeline, how do you manage all that? It can be a challenge. So the CDK has an assets library built in where it can actually build, bundle, and deploy the assets for you, and then sync that Lambda function to those assets without you having to figure all that out on your own. So this is a really, really powerful construct, a powerful abstraction that will save you a lot of time and effort as you're building in the CDK and so on. Okay, so what we're going to do is we're going to use the lambda .code, and then we're going to say, code dot from asset. So you can see all the options that are available to me. I could do from inline, I could do from an image in ECR. So if you do manage your builds separately, you can still reference those images if you're using Docker, or if there's a particular bucket location that you store your code, you can still reference those. You don't have to use the assets library here. So we're going to say, we're going to do from asset. Now, from asset is going to look locally on the file system based on where I tell it to look, and it's going to build that function based on where that code lives. So we're telling it to look in the Lambda directory and look for this hit counter file, this hit counter.js. So that's all I had to do. You see, that's it. Now the CDK, when we deploy it, it's going to bundle that. It's going to zip it up, ship it to S3, and then deploy that Lambda function pointing to that particular artifact. So the last thing we'll want to add is our environment variables. And again, here's where you get dynamic, because again, we don't want to hard code things. If there's anything I can pass on to you during this, it's don't hard code into your application. You want to be as dynamic as possible, especially when you're bundling your application code with your infrastructure as code here. It's a lot easier to bring those values in dynamically. So we're going to say props.downstream.function name. So this is that function name that we're passing in to our construct. So remember, the downstream function is the one that this function, this construct creates, is going to trigger. And so we pass that in, and we're also giving the table name, providing the table name as an environment variable. Okay, so we've kind of talked about all the things we're building. And it's important to mention, like in the workshop here, you see there's a mention of these late bound values. So these values are dynamically generated as in their placeholder, they're referenced as tokens. So what will happen is the CDK is going to figure out when it compiles everything, what that resource is that it needs to access, what that name is. It'll know how to reference it, what that function name is, and so on. So these are really good once you synthesize your code. You can't work with these inline in the code in this sense. So because they're token values and they'll be assigned later in the synthesis process, you can't really mess with those actual values in your code at runtime. Okay. We have our Lambda function. We have our construct built. Our construct is building a DynamoDB table. It's building a Lambda function. It's referencing the code from the asset directory and the Lambda directory. And then it's also, we reference that DynamoDB table. So I'll leave it up to chat if anyone wants to jump in. Obviously, you're probably going to notice we're missing some things, which we'll touch on in in just a little bit. But before we do that, we're going to go back to our main stack. Okay, so we've created our generic resource. We're going to go back to our main stack here, and we're going to now import it. And we're going to import hit counter from our hit counter construct. And let's create this. We're going to call this hello with counter. And we're going to instantiate that new hit counter construct. Hello hit counter. And let's get rid of that nonsense. Okay. So we're passing in our Lambda function here. So if you see, again, because it's strongly typed, if I tried to just pass in a string, it's going to fail because it is expecting a Lambda function object to be passed in. So we're going to, go back, and we're going to pass in this function. So it's our downstream function. We're creating our upstream function that points to that downstream function. And then what we're going to do is we're going to point our REST API, because now this function here is becoming abstracted away, or it's moving back a layer in the stack, because we're putting that other function in front of it, which writes to the table and then calls this function. So for our front end, our REST API, we're going to actually call the hello with counter, and then we're going to call that handler, that function. So remember, we made that publicly accessible, so it's public, it's accessible within the object, so we can reference that Lambda function object as we build. Okay, so now we're going to deploy this, and I'll move this here so hopefully we can see a little better. And if we want, let's run a CDK diff first, because we should do that. And let's see, let me grab profile. Let's see if that. Yeah, I have something up with my environment variables here. So what it's doing right now is it's bundling those the assets. It's going to figure out where it needs to deploy them, and then the CDK is going to deploy all of those resources that we've defined. We've created our generic construct that basically this module. And if you're familiar with like the Terraform world, it's like creating a Terraform module and creating reusability here. And we're deploying everything. So you'll notice a lot of things are being created, like an IAM role, for example. You may see I'm not creating any IAM roles here because when you use higher level constructs, a lot of this is abstracted and you don't have to think about these things. So a lot of things will be built in as defaults that you can either override or stick with. So let's see here. I hate that I have to look this. Got my camera in the way. Super cool. Oh, cool. So Connor had mentioned using CDK migrate. So we actually have a video on our channel where we walk through CDK migrate. What's cool about CDK migrate is that tool can look at existing resources in an AWS environment and import them into being managed in a CDK application. Or you can take a CloudFormation template and simply use the CDK migrate command, and it'll convert that template into a CDK application code. Really cool. Check it out. Okay, so our resources are deployed. So we'll want to test our function. So I think the first thing we're going to want to do is just curl this sucker. And it doesn't work. We expected this. I expected this because I know what's happening. So remember, I had mentioned earlier that there's something missing in our construct that we created. So what I want to do now is I want to actually go to the AWS console. Don't do that. Let's open it in a new tab. And then we're going to go here and we're going to go here. Okay. So we're going to open up the AWS console and let's look at the logs for this Lambda function and let's see what the heck's going on. So clearly I've deployed something that's broken. I need to now figure out what broke and troubleshoot it. So I'm going to find my Lambda function, which it's the hit counter Lambda. Man, it's really hard with the super zoom in. So let's try to do this one more and then we'll do this. Okay, so you can see here's our code. Let's go to monitor and then the really nice thing about the Lambda console is it has all of these metrics and logging all built into it, and it can get you to where you need to go pretty quickly when you're troubleshooting. So we're going to go to CloudWatch logs, and let's look at our logs. Let's see what is going on. And I'm going to search the entire log group. I'm going to search all the log streams. So I can see it initialized, it started, but we can see we're printing our event here, which looks good. But then here we have an error. So let's zoom in a lot. And you can see here, this error is an access denied exception. So looking at the code here, it's saying that my Lambda function, the IAM role attached to my Lambda function, is not authorized to perform DynamoDB update item on that DynamoDB table. So very clear, we know what's going on. We now need to go back and grant our Lambda function access to that DynamoDB table to not only read, but to also write to that table. So we're going to zoom back out a little bit here. And we're going to, you can see we looked at the logs, we got the error message. So now what we want to do is we want to grant access. So we're going to go back to our construct. And now this is the grant methods that I was talking about earlier. If I were to author this on my own, I'd have to create an IAM policy, create a, update that role, attach that policy to the role, scope the policy to the things I need. And if you, worked with IAM, IAM's wonderful, least privilege, very important. It can be cumbersome, right? It can be tough to constantly author IAM policies and to refine them and to work through them. So if you don't have the time and you don't want to deal with that, cool, no problem. Because what we can do here is we can say table.grant and look at all of these grant methods that are available to my DynamoDB table. So I'm going to choose the grant read write data, and I'm going to say grant this to my Lambda function. And instead of authoring, an IAM policy, like, this long and all that, I have one line of code that says scope the access of this Lambda function to read and write data access to my Lambda function. So that's it. That's all I had to do. And now that's going to give my Lambda function the access it needs, my Lambda function the access it needs to read and write to this Dynamo table. So that's all we had to add. And now we'll go back, move this up, and then we're going to deploy it again. Yeah, look, IAM is much needed. Again, when you're building in the cloud, you have to be really smart about how you scope your IAM and your access, because you want to be careful. You don't want to just give all access to everything. You want to scope it to least privilege, just to protect yourself as much as possible. So yeah, it personally, the more I can avoid writing IAM policies and leveraging these higher level abstractions that take care of the gluing these resources together, I'm all for it. Okay, so we've deployed. Now let's hit that endpoint again. Okay, so it's the same endpoint. We're going to curl it, and we have another error. I'd be lying if I didn't admit that I knew that was going to happen. But let's go back to the logs and let's see what the heck's going on. So if I look at the logs, we'll go back here. And actually, let's also open up DynamoDB. And let's look at the table. We'll go to tables. This is our table that our Lambda function writes to. Let's first just confirm, was it able to write? And you can see it did actually work. So the function now can write to this Dynamo table. So that's good. We've made good progress here. So hello, still not working. And I can refresh and you can see it's writing to the table. This is good. So if I look at the logs, there's still something missing though. So we're going to go here and we're going to scope this to, let's go for like the last 5 minutes. And you click this part of the logs here. And again, we're getting another access denied. So this time, our Lambda function is not able, it does not have the permission to invoke that backend Lambda function, which is where it's going to return, what that backend function is supposed to return, for the API. So we're getting an access denied. We can't invoke that function. So once again, it's going to be rinse, repeat. We need to make sure that we can grant that access to this Lambda function. So what we want to do is we want to say props.downstream. That's our function, right? We want to grant invoke to this Lambda handler, to our Lambda handler that we're creating in the construct. And this is going to give that permission to allow this Lambda function to invoke the backend Lambda function. So once again, we're going to CDK deploy. And you can see this is all here as well in the workshop. And again, if I were to run a CDK diff, what you would see is the IAM policy changes to allow access to invoke that function. So I'm not authoring IAM policies. I'm leveraging these grant methods to handle the granting of access to these resources. And I'm relying on the CDK and these powerful abstractions to do all the heavy lifting for me, which again, look, our jobs are tough. And, every day, whether you're working in DevOps, whether you're a developer, cloud operations, whatever it is, there's so much going on. So the less that you can worry about when you're building, the better, because ultimately what matters is your quality of life. You're able to deploy and you can focus on, the things that really matter to your role, to your business, and to making sure you're continuously moving fast and all that good stuff. So we've deployed our application with all of the proper access in place in our CDK code. So we're going to curl this one more time. And if it doesn't work, then something else happened. So it appears that it worked. So a Lambda deployment was taking place. And so you noticed that I did get the old function while the rollout was happening. But now I'm getting the hit with the new function, and you can see it's working. So this was back when I was working on the CDK watch command in the previous session. That's why it says CDK watch. But you can see our application is now returning from the back end because we were able to grant the access, grant the proper permissions, and all that good stuff. So, I hit it a few times, but now it's still not working. Hello, working. Let's just hit it a few times. And you can see coolness. And we're all good. So again, during that rollout, I still may hit that old function at times, but you can see everything's looking really good, and our application is deployed. And we did this all through our CDK code, which here is just a few lines of code, and then we created our reusability in that construct here for us to reuse this code as we want to build this functionality out more and more. So we tested it. Let's go back to DynamoDB and let's see what that looks like. So again, I got to zoom out a little bit here. Let's do this, reset, and then we're going to run. So there you go. So our application end to end is working, and it's writing to the DynamoDB table. It's calling that backend function and returning that to the API caller. So that's it for this particular session. And so let's see, Carlos, I didn't know those grant access methods existed. Yes, check them out. There's so much power in the CDK, and honestly, it's hard to find all of these things on your own, like to discover this. But anytime you're working with a resource that is going to require access of some sort, so like a Dynamo table, even like an RDS database, if you're using IAM authentication, an SQSQ, S3 bucket, and so on, there's a good chance if it's an L2 construct or above, or just an L2 construct, there's going to be a grant method associated with it that will help simplify a lot of this for you. So, yeah, this is perfect. This is exactly what you would want to use. So now, so you're using an SQS queue, and you're saying you want to grant send messages to the containers that are running in that task definition on ECS. So it definitely saves you a lot of time, a lot of effort. And of course, I always preface, I want to say that, like, you have to know your organization, your requirements, and all that to make sure that what you're building falls in line with all of that. But that does lead into another session that we'll have here in the next few weeks, which will dive into integrating policy as code into your CDK templates, because that's another really important thing that, before you deploy, you want to catch any possible issues or, security violations pre-deploy rather than post-deploy. So that's it for this session. The next session, what we're going to touch on is using external construct libraries. But also stick around because we're going to do a quick bonus after this. So we'll use external construct libraries. So we'll actually go and leverage a library that was built externally, which provides a UI that provides visualization into that DynamoDB data, that hit counter, so we can see that in real time. So that is what we'll do next. Now, the other thing with constructs here that I just want to touch on is you can take these abstractions you build and you can bundle them into packages and then reuse them and import them as libraries across your CDK code bases across your organization. So, if you want to build patterns that fit within your organization, that have, meet certain requirements, you can bundle all of those up into a construct and then ship that construct as like an NPM package or a PyPy package. And you can then just leverage those in your CDK applications by importing them and building what you need. So there's a ton of power with building constructs in the CDK. Okay, so now off the script here. So I mentioned Amazon Q. If you're not familiar with Amazon Q Developer, it's a super powerful AI assistant that integrates with a whole bunch of AWS services. But my favorite feature is the inline editor suggestions. So you saw that here with the code suggestions. Like, it gives me suggestions on what I should write in my code, but it also has chat functionality. So this chat functionality is really cool. Let's save this. And again, remember I mentioned that our hit counter code was using the SDK v2. So I'm going to ask Amazon Q to read this code and to convert it to the AWS v3 JavaScript SDK. So again, the prompt engineering is going to become the next big thing. So I'm going to do my best here to ask it appropriately. So upgrade the hit counter code to use the AWS SDK v3. So I'm not even telling it what language. I'm just saying I want you to use the v3 SDK. And then it's going to tell me. So let's pull this out a little bit so we can read what happened here. Okay. So the first thing it did is it gave me this code. So it gave me updated code to work with the new, the version 3 of the JavaScript SDK. And in addition, it's telling me what changed. So it's telling me, here are the libraries you're going to import. Here's the constructors you'll use. The way you invoke is a little different. And it removed the require statements that were from the SDK v2. So Let's just take this. I could just insert it in line. Let's see if I don't think replace is an option. Yeah, so I'm going to copy this code. And then we're going to go back. Actually, let's move that away. All right. And I'm just going to paste it in. So now here's our new code. So I've replaced everything with what Q generated, and I'm going to deploy it, and I'm going to see what happens. Okay. So already, though, things look pretty good. I don't, so if you look here, it's creating our DynamoDB client, importing the Lambda client, the invoke command, update item command. We're instantiating our clients here. The one thing that I see oftentimes, those maybe regions passed in, so you could do like, you could pass in your region if you wanted to. I'm not going to, because I'm going to let the SDK follows the credential chain. So like that means it'll look at like an IAM, the IAM role that's attached to the resource first. If the access isn't there, it'll look for if you have like the AWS config or AWS keys hard-coded, or if you have environment variables with the AWS access key and secret, and so on. So it kind of follows that path. Obviously, again, another disclaimer, never hard-code your keys, never use static keys. Don't hard-code those in your code. Don't do that. Leverage IAM roles policies to deal with resource-to-resource communication and all that good stuff. Okay, so we're going to deploy it. Let's just see if it works. Oh, you know what? Before I deploy it, we're going to go to lib, and this was our hit counter, right? So we're going to upgrade. So you can see we were using node 16. Well, now that we're using the latest JavaScript SDK, I'm going to upgrade to node 20 because I want to be up to date here. Oops. So we'll use node 20, and we're going to point to the same code and all that good stuff. And we're going to deploy. So again, these AI assistants, Amazon Q, this integration into your IDE is just super helpful. Having the chat experience where you can ask questions. So if this breaks somehow and it doesn't work, I'm not going to use my brain. I'm going to go to Q and ask Q to fix it. And we're going to see if we can get Q to get us to where we need to go. So we're deploying our new function, and then we're going to hit it again, and let's see if it breaks, because it may. We don't know. So as that deploys, let's just make sure everything else looks good here. We upgraded to node 20, same handler, everything remains the same. So let's do this. And we'll do this. Okay. All right. So curl, let's see. Did you work? It broke. Okay. So let's see what happened. So yeah, curled it a few times. Something's going on. So we'll go back to our CloudWatch logs. And let's go here. All right. So if we look. Okay. So this is a strange error. Oh, let's look here. So runtime user code syntax cannot use import statement outside of a module. Okay. So this is good. So let's go back to Amazon Q. And I'm going to say, actually, I'm going to do this. I'm going to copy this, and I'm going to say that I got this error. Again, the zooming in stuff, bear with me here. I deployed this to Lambda, and when invoked, received this error. Let's see what it can do to help fix this for us. Okay. All right, so it tells us what the issue was. So it says the issue is with the import statements because of the runtime we're using. So we're going to just change this to const, and let's see. Oops, what did I just do? Let's do that. Okay. So this is what they're telling me to do. I'm going to follow what this is telling me. So it looks like everything remained the same. It was just, let's see here. No, okay, you know what? I could copy everything and paste it in. Or I could just do this. All right, so this seems to be everything we need. Let's look here, and then let's read what they said. So it replaced the import statements, and it removed these. What happened here? Can I make this bigger? Yeah. So it should be the full object names. So it's saying this should resolve it. So let's see. All right, so we have this all working here. And actually, you know what we could do? Why not just copy the whole thing and replace it? Because that feels better to me. Okay. So we're importing our objects properly, our libraries. Let's deploy it again. So what's really nice about these AI assistants, is you still know how to write code, right? You're still writing this code, you own it, but it just makes your life a lot easier rather than having to, go to search engines, trying to figure out the problems. You can, talk to this chatbot in your IDE that can read your code, can look at the error, and give you suggestions on how to fix it. Because again, it's not always going to be perfect. And, you can't expect perfection. But it gives you a start. It gives you a good head start and saves you a lot of time. And for me, again, as I mentioned earlier, if I can save any time in my workflow, I want to do it. Call me lazy, call me what you want, but it's just my preferred way of working. So let's see. And look, we're getting close on time here. So I'm going to look at the error. We're going to see what the next thing is. And it could still be just deploying. Let's go back to the function, actually. Back to our functions. What is this? Hello hit counter. And we'll go to our logs. Where'd our logs go? Am I crazy here? Let's do a hard refresh. It's not loading. There we go. Okay. So go to CloudWatch logs. And let's go to this latest one. And let's see what happened. So again, position 3. Okay. So it's saying that, line 35, it didn't like this. It didn't like this. So again, I can go back, ask for more help, and so on. So I'm going to do that. And let's see what it says. And, it's really nice. It apologizes. It's really nice. So anyway, what I'll do is let's just copy, replace, and let's see how this works. But again, the idea here is this is supposed to help you just move faster in your day-to-day workflow. It's not always going to get it right, but it at least gives you a start. And you can see I can work through the code. I can deploy it. And I can try to figure out what's going on with it. I can test it locally and try to figure out what's happening. Rather than having to rewrite all the code myself, I can just fix what was provided to me and then work through it. So I'm going to let this deploy, but I'm probably going to wrap here. And again, I want to thank everybody for joining. A couple things while this deploys. Number one, please, if you haven't subscribed to our channel, CDK Live, please check it out, subscribe. If there's content you want to see, please reach out as well. We are available on the cdk.dev Slack channel. So if you want to talk about anything related to CDK Live, there's a CDK Live channel there in that Slack group. And yeah, so we can just try one more time. And if it's broken, then I'm going to figure it out and I'll post something on it later. Yeah, so still something's not working. But anyway, it still helps me because I'm close enough and I can work through this and figure all these things out. So that's it for this session. Again, if you want to check out our other two sessions, which is the introduction and deploying a serverless API, check out the channel and you can see those two sessions. I posted the links earlier. Thank you so much for everybody for joining, and we will definitely catch you on the next show. But in the meantime, have yourselves a good day, good evening, good afternoon, and good rest of your week. Thanks so much.